All right, so review number 4, we're talking about graphs and interval notation, specifically greater than, less than, inequalities. This is again review. Really, if you had intermediate algebra, you would have covered this and know this. I'm glad to go over it, but I say that as kind of a gentle warning. I want to make sure you're in the right spot. Really, we're gonna fly because they assume you know this, and then we'll use it in all the rest of the course. But I'm glad to answer anything I can. Just want to help you discern if you're in the right spot and if this is going to work for you. Because again, this is easy stuff compared to what we'll be doing in a couple of weeks. All right, so that first one, number 1. So they give a graph, and they have part of it shaded. I don't know if you can see that the best. There's like a bracket right there, and there's a bracket right there on those two ends. Let me draw that a little bit better. This is a bracket here, and that matters. Sometimes it's brackets, sometimes it's parentheses. Do you know the difference between those? The bracket, if you have a bracket, so well, let's first off, let me say this one's going from, where does this go? -1 all the way to 8, and it's a bracket here and a bracket there. So use interval notation to describe the graph. So that would be bracket -1, 8. That's interval notation. And what interval notation does is it goes from the left edge to the right edge. So it's saying all the numbers are shaded. You know, it's bracket, left edge, right edge. It's saying all the numbers are shaded from -1 all the way to +8. The order matters. You've got to have the left edge coming first and then the right edge. And then the second part says, use inequality, use an inequality involving x to describe it. So how do you write that same chunk of numbers? So we're talking about a chunk of numbers that go from -1 to +8. And there's basically, you know what we're doing today? It's like me saying one, uno, or one in some other third language, right? So we're saying the same thing. We're saying the chunk of numbers that go from -1 to 8 on a graph. That's what we started with, is that graph. Secondly, in interval notation, that's the brackets, left edge, right edge. And thirdly, with like greater than, less thans. So we're just getting comfortable in saying a chunk of numbers in 3 different languages. Graph, interval notation, and thirdly, how do you say it with inequalities? Do you know how to say the chunk of numbers from -1 to 8 with like greater thans and less thans and an x? What do? We go like this. That means the same thing. That means x is all the numbers from -1 to +8. And the direction of those inequalities really matters. So why? What are they actually saying? Well, you remember how the symbols work, right? If I, well, how about I go 8? 8, that says 8 is greater than or equal to 2, right? Remember the way the symbols work? So there's a wide side and there's a narrow side. So a greater than or less than symbol has the bigger number. This is the bigger side of the symbol. It's the wide mouth side. This is the smaller side of the symbol. So the bigger thing goes on the wide side, the smaller thing on the narrow side. You could turn it around, and then the bigger thing will go over here, right? And the smaller thing will go over there. So therefore, what is this saying? Well, if you look at this statement in parts, let's look here first off. What is that, just that part? Forget this for a minute. What does just that part say? X is what? Greater than or less than? Less. X is on the narrow side of, right? 8's on the wide side. 8's on the wide side. X is on the narrow side. So that's saying X is less than or equal. That's the bottom of an equal sign. So that's saying X is less than or equal to 8. So in other words, it's smaller than 8. It's something like 7 or 6 or 5. It could be 8 itself, right? It could be equal to 8. It's 8 or 7 or 6 or 5 or 4 or 3, etc. That's what that part of the statement is saying. And what is the other part of the statement saying? Let me write it again. What is this part of the statement saying? X is what? What side of the symbol is he on? Forget about the 8 stuff. Not looking at that right now. Just Just that right there. Is he on the wide side of that symbol, of this other symbol here? Is he on the wide side or the narrow side of that other symbol, of this symbol? He's on the wide side, isn't he? Right? You with me? Which means he's what? Bigger or smaller? Bigger. X is bigger than -1. What numbers are bigger than or equal to, I should say? Bigger than or equal to -1. So that means he's -1 or bigger, huh? -1 or 0 or 1 or 2 or 3 or 4 or 5 or 6, right? Like that. So put them together, he's bigger than -1, smaller than 8. He's between -1 and 8. That means the chunk of numbers between -1 and 8. See how it's saying the same thing as the other two? So those are three languages that are all saying the same thing. All right, let's keep moving then. So number 2. Let's try it again. So here they are. They're giving me a chunk of numbers. They're starting with a graph. And they want me to select which one of those is the correct interval notation that represents that. So what's the, so we're going to put a bracket and a bracket, right? Let me help you. This one's is a little different, so let me jump in. So it's got brackets on both sides. Remember what you're supposed to put? Left edge, comma, right edge? That's how interval notation always works. Left edge to right edge. You say the chunk of numbers that go from the left edge to the right edge. So what is the left edge right here? It's like -8, right? Can you see that? Is it kind of small? -8. And what is the right edge? We might say 12, but actually there's an arrow there. There's not really a bracket. It doesn't stop there like the last one did. See how on the last problem, number 1, it stopped at 8. There was a bracket there stopping it, huh? But on number 2, see the arrow, which means it just keeps going forever to the right. How do we say forever to the right in math?
Infinity.
The infinity symbol. Yeah, which is the sideways 8. And now let's talk about the difference between a parenthesis and a bracket. If you put a bracket on something, what you're saying is it hits that number straight on. Do you remember that? Like if I go, let me come over here and go like 1 to 4. If I go like that, that means it hits the 1, and it hits the 4 straight on. Whereas if I go 1, 4 with parentheses like that, it's close to 1 and 4. Meaning it's all the numbers between 1 and 4, but not quite touching the 1, not quite touching the 4. It's around them. That's how I think of it. When you have a parenthesis and it's a rounded edge, it means it's around. When it gets close to 1, it's like 1.0000001. You know, it's really close to 1, but not quite 1 right on the money. And it gets close to 4, 3.999999, but not quite 4 right on the money. That's what a parenthesis means. Whereas if you have a bracket, it has a straight edge. You're straight on that number. It's all the numbers from 1 to 4, including 1 straight on and 4 straight on, and everything in between. 2, 3, 2.6, 2.89, 3.47, you know, all the numbers on the number line from 1 to 4, including the 1 straight on and the 4 straight on. That's what a bracket means. If you have parentheses, it's close to 1 and close to 4. It's around them, but not straight on them. Okay, with that in mind, what should we do for this infinity? Should we put a bracket? Can you get straight on infinity? No, you might go to the doctor's office and say, I waited forever. But you didn't really wait forever. You just started to approach forever, right? It felt like. So it's parenthesis, isn't it? We never put a bracket by infinity.
It's always right. Yeah.
Always, yeah. So infinities always get a parenthesis because you never write on infinity. Is that good? And then how about the second part down here? Choose the correct inequality. So how do we write the chunk of numbers? So again, we're doing 3 languages, 1 in Uno and 1 in some other language. We're saying this chunk of numbers in 3 different languages on a graph with an interval, and now with a greater than, less than. How do you say all the numbers from -8 to forever positive? Which one of those means the same thing? Yeah, you're right. X greater than or equal to negative 8. Why do we have to have the equals bar? Why couldn't it just be x greater than negative 8? That'd be wrong. What's wrong with that? Yeah, same thing. Some books use the open circle closer. Yeah, because remember, the bracket at the negative 8, right? And the bracket on the graph, which means you're straight on the negative 8, which means you can equal the negative 8, can't you? So we need to have the equals bar greater than or equal to negative 8. Makes sense? If they had a parenthesis here and a parenthesis here, then I would not have the equals bar, because you could not be straight on the negative 8, only close to it, so just barely greater than it. So that's the difference. Questions I can answer? So 3 languages for saying part of a whole. All right, let's try. Number 3 is easy. I'm going to move on. Number 4 is easy. I'm going to move on because it's hard stuff. I want to slow down there. 5 might be good. Let's do number 5. Can you see it? I'll write a little bigger for you. -9. So what they're going to do is they're going to basically just mix between the 3 different languages. Yeah.
Real quick.
Good question. Yeah. Oh, yeah. That's what you mean. Yeah. So on 3, looks like the left edge has a bracket. I don't know if you can see it very well.
Yeah.
And the right edge has a parenthesis. Right? So that was just like, let's look back. See how number 1 had a bracket on both ends?
Yeah.
And so we just wrote our interval with a bracket on both ends. So on number 3, it has a bracket here, and it has a parenthesis there. So we just do the same thing. We'd write a bracket, and we would write a parenthesis. So we just follow suit. Whatever's on the graph, we put in the interval. Same-o, same-o.
So the parentheses is kind of equal to like when it's an arrow.
No, arrow goes forever. Infinity. Yeah, no, that's different. Is that making sense? See, on this one here, on number 2, that was an arrow, so it doesn't stop there at all. It just keeps on going, right? I didn't put 12 in my thing, did I? Because it doesn't stop at 12. It just keeps on trucking, right? So the arrow means it goes right past there. But if there's a parenthesis or a bracket, it stops there. So this one would stop at the 7. Like that. And then how would we write our interval? So we're going to put a -8 and a 7. The x goes in the middle. The x means the chunk of numbers. Yeah, so you put both these, but which one gets the equals? The -8 because of the bracket, huh? And the other one doesn't.
If there was a bracket on the other side of 7, it would also get the...
Yeah, if the 7 had a bracket here, and thus it would have it here, and then this would be equals.
Okay, and then if it's one parenthesis and one bracket, the one with the bracket gets the equal sign?
Right.
Okay.
Yeah, so just know the rule. Bracket, remember what it means? It means straight on it. So it's always going to get the equals, isn't it? And the parenthesis just means it's around it, so that's never equal. That'll always be how that works. All right. So number 5, then. So they're giving us that, and they want us to go to the right graph and the right interval. Let's do the interval first. So how do you write that? Can you write that as an interval? So I'll let you do that. So this would be bracket -9 parenthesis 8. Again, because the equals means I know, that's right. I remember I have a saying, help, bar bracket, BB, bar bracket, right? So if you have an equals bar, that goes to become a bracket. And the other one, the 8 has no bar, so there's no bracket. It's a parenthesis. So that might help. Bar goes with bracket, B with B. All right, and then on the graph, they're pretty small. It's hard to tell. Which one has a bracket on the left and a parenthesis on the right? Oh, yeah, it looks like C does, huh? Bracket on the left, parenthesis on the right. That's the only difference. All right, so let's see. Let's try, how about number 7? Yeah, can you take that one? and write it as an interval, and then write it, and then pick which graph is showing it. X greater than -5. How do we write that interval?
So X could also count as infinity.
How about we do this? How about we go first to the graph, and then the interval is easy from the graph. So which of these 4 graphs, now what X represents, let me help with that. What X represents is the chunk of numbers. So the X is the shaded chunk of numbers. So what is it saying about X? Greater than or less than? Greater than. Is that, so if I was to do a number line, okay, and put -5 right here, X is going to be the shading. X represents the shading, the chunk of numbers. So where are the numbers? Are they to the right of the -5 or the left of the -5? Are they bigger or smaller? Bigger. X is bigger. Bigger is always to the right, isn't it? So it's over here, isn't it? And do I do a parenthesis or a bracket? Yeah, no bar. No bar down here, no bracket. BB, right? No bar, no bracket. Parenthesis, like that. So it's, what, D? D, that makes sense so far? So all the numbers bigger than -5, to the right of. Bigger things to the right, smaller things to the left. And now, it's easy to go from there to your interval. Why? Well, remember how you always write an interval? You write left edge, comma, right edge. That's always what we do for an interval. It's, 2 parentheses or brackets. It might be brackets or whatever. But it's going to be left edge, comma, right edge. So what's of what? Of the chunk of shading. Of the chunk of shading, right? Because that's the numbers. That's the X. So of the chunk of shading, what's the left edge of the chunk of shading? -5. What's the right edge of the chunk of shading? Yeah, forever to the right, huh? So it's going to be I'll put over here, parenthesis, -5, comma, infinity. Why parentheses? Yeah, no bar, no bracket, right? It's never straight on the -5. It's just greater than -5. It's close to -5, huh? And you're never straight on
Flipped it around and you just have to figure it out which one it was.
What's that?
So they just flipped it around pretty much, they just put the X before. Because it could have been -5 was greater than or equal to.
Good point, yeah.
So they just flipped it pretty much and put it their own way.
So you can write it this way, or, yeah, you could put the -5. Notice those two are saying the same thing, aren't they? Yeah, and they can write that either way. See how they're on both, see how in both cases X is on the wide side, the open mouth side of the symbol? Do you see that? X here is on the what? Wide side of the symbol. X here is on the what? Wide side of the symbol. So both those are saying X is bigger, aren't they? Bigger than -5. So good question, good clarification. That's correct. They could do that either way, and it says the same thing, doesn't it? So students who don't really understand this very well, they'll sometimes think that this is what I've run into over the years. They'll think, oh, this always means less than, this always means greater than. No, not so. It depends who's on which side, right? This is the wider side, so if X is over here and 2's over there, then he's greater. But if he's here, then this is less than 2, because now he's on the narrow side, huh? So you just got to look at which side they're on. That's how you read the symbol. Does that make sense? If you're on the narrow side, you're smaller. If you're on the wide side, you're bigger. That's the rule on that. Is that good on that? All right, so I'm going to move on from those. I think those will be not too bad. It's hard to read that one, isn't it? Can you read that? I can't hardly read that. What is that saying? So what I mean by the number line, I mean you're going to have a number line, and you're going to have shading somewhere on that number line, right? And we know we're going to have 3 on there.
Yeah.
So 3's right here, okay? And which side do we shade? We're going to shade one side or the other of the 3, right? I'm going to have a number line 3, and you don't have to put 3 in the middle, but whatever. I'm going to either shade the right side or the left side. Which side? Left. Yeah, because it's to negative infinity. Negative infinity is way over here. Regular infinity is there, huh? Positive numbers to the left. That other numbers to the right. So now, am I going to put a bracket or a parenthesis at that 3? Well, it's got a bracket, huh? So bracket, and you shade that way. Good there? So far. Now, how do you write that same thing as like a greater than, less than inequality down here? Well, you're going to say something about x, right? Now, what you're going to say about x, you're really saying about the shading, which is right there. So remember, x is the shading. What you're saying about x is what you're saying about the shading. The shading is the chunk of numbers. The x is the shading, is the chunk of numbers. They're all one and the same. So what is true of x? Is he to the left of the 3 or the right of the 3? To the left. So does that mean he's bigger or smaller? He's smaller. So x is smaller than 3, isn't he? And now, should I put the equals? Yeah. Because I have a bracket. Remember, bar, bracket. They go together. If you have a bar, you have a bracket. If you have a bracket, you have a bar. They go together. Yeah, x is less than or equal to 3, huh? X is all the numbers less than 3. The shading is all the numbers less than 3. All the numbers from negative infinity up to 3. Making more sense? Feel more comfortable with those 3 languages? Different ways of saying that? Yeah.
Can you explain?
Let's do that. Let's just backtrack to number 7. In fact, let me just stick it right beside this one so we can have them both here. Nice to see them both. Yeah, so how does this compare like number 7, which says x, okay, it says that, and they want me to, let's first go to the graph. I think the graph is the easiest thing to bridge between the other two. So let's go ahead and put it on the graph. So how would we put that? Let's put -5 down right there. Now, x is going to be one side or the other. So is x to the right or the left of -5? What is the statement saying? Yeah, because he's on the wide side of the symbol. He's bigger, right? So the shading, the x, is that way. Parenthesis or bracket? Parenthesis, no bar, no bracket, right? There's no bar here, so there's no bracket, right? There's a parenthesis. Good there? So far so good. The x is all the stuff to the right of -5. All the numbers shaded to the right of -5. Now, how do we say that as an interval? Well, remember, interval is parenthesis, left edge, right edge. So what's of the chunk of shading? Exactly. Everybody hear me on it? The interval is left and right edge of the chunk of shading. Yeah, so here's the left edge, here's the right edge, exactly -5 to infinity, because this right edge is infinity. There it is. 3 languages to say the same thing. Good. Other questions on that one? So let's solve a greater than question. Remember how to solve? It's just like solving equals. Just do the same thing you would do if it says equals. So x is saying, I want to be alone. So the greater than symbol is like a wall of separation, just like an equals is. And you just want to get x. X is saying, I want to be alone over here. Get me alone. Get rid of this 2 and -6 so that I can be alone. So go ahead and do that. So what do we do first? Add the 6 to both sides. Good. And then we get 2x greater than 14. And then last step is usually divide, right? And it is here too. And so it's x greater than 7, right? Now they're going to ask you to put that on a graph and also put that in an interval. Can you put that on a number line now? That is, remember, just put down the 7 in the middle and then decide which side should be shaded, right side or left side, and whether you should have a parenthesis or a bracket. And then after that, then do an interval, which is, left edge, comma, right edge, parentheses or brackets or whatever. See if you can finish that up. Okay, so which side of the 7 is shaded, the right side or the left side? X is what? What side is X on? Is he on the... He's on the wide side, isn't he? Which means he's bigger. The X is over here on the right side, isn't he? Because he's bigger than 7. So the shading is to the right of 7. The X is to the right of 7. Parenthesis or bracket? Yeah, no bar here. No equals bar. No bar, no bracket. Parenthesis. Good there. Now... What's that?
Why was there a parenthesis?
Because there's no bar.
Oh, okay.
So if there was a bar, there would be a bracket. So bar goes with bracket, no bar, no bracket. There's a parenthesis. Okay, now for the interval notation, we're going to put left edge, comma, right edge. So what's the left edge of that chunk of shading? 7. And what's the right edge of the chunk of shading? Forever to the right. So it's 7 to infinity. Both parentheses, no bars, no brackets. 7 to infinity. That's the interval notation. All the numbers between 7 and infinity. Good on that? Questions on that one? Now, right beside it, probably should have left a little more room. Let's do number 14, which has an extra, well, actually, let's just do it on a fresh thing here. Minus 2, 5x minus 1, greater than 12. Same thing, try that one. X is saying, I want to be alone. But there's one special rule. There's one special rule that you need to remember for solving greater than, less than, that'll come into play on this one. Well, let me let you work it out. All right, so we distribute, right? Minus 10x plus 2 greater than 12. Good so far. The negative 2 times the negative 1 made positive 2. And now what do we do to finish solving to keep solving for x? Next step? Subtract the 2 from both sides. Draw your line. Show the results. Minus 10x greater than 10. Good. Last step to get x alone. Divide by negative 10, right? Cancels out. X. Very good. Yeah. That's the rule. Do you know about that rule? Right here, you got to cross out the sign and turn it the other way. Let me write a note. When you multiply or divide either one by a negative number, you must flip the symbol. You must flip the symbol. So it ends up becoming negative 1. X is less than negative 1. Yeah, so that's the trick you got to remember. Good job. If you remembered that, that's the trick you got to remember. Whenever you solve a greater than, less than, if you divide or multiply by a negative, you've got to flip the symbol. Otherwise, you'll lose the truth. I don't want that to be just some rule Mr. Heron says. Let me show you an example. What if you had 10 is greater than 2? And that's true, isn't it? 10 is greater than 2. 10's bigger than 2. What if I divided both of those like by negative 2 and didn't flip the symbol? What would I then get? What is 10 divided by negative 2? Negative 5, right? 10 divided by 2 is 5, and positive over negative is negative. And what is 2 divided by negative 2? Negative 1. And which one of those is really, let's put them on the number line for right. Here's 0. Whoops, I better put 0 somewhere else. Here's 0, here's negative 1, here's negative 5, right? Negative 1 means you're like $1 in debt. Negative 5 means you're like $5 in debt. I'm always there, pretty much. I have kids in college. So which one's bigger? Which one's a better financial situation? Negative 1. You're only $1 in debt, huh? That's the bigger one. But do you see how this is not saying that? It's wrong because we didn't flip the symbol. I just wanted to prove to you that why do we flip the symbol? Because it's true. If you don't, see how you lose the truth there? See how it's saying the negative 5 is on the wide side, is the bigger one, but that's not so. The negative 5, right, is not really the bigger one, is it? The negative 5 is more negative. You're further in debt. That's the smaller one. But the symbol right now is saying the negative 5 is the bigger one. He's on the wide side. That ain't so. So in other words, the only way you're going to keep the truth is if you flip the symbol. Right there, you should have flipped the symbol when you divide by a negative. I'm just proving it with numbers. And so when there's an x involved, it's the same thing, because an x is just a number we don't currently know. So that's the rule. Whenever you divide by a negative or multiply both sides by a negative, you've got to flip the symbol to keep with the truth. So, all right, x is less than negative 1. And then you could put that on an interval. Can you do that? Can you draw it on a graph first off? So put that on a graph and then write that in interval notation. Give you a second. So remember, you put -1 in the middle of the graph, and you decide which side to shade, right? The right side or the left side. You're shading the x. What does it say about x? X is what? He's on the narrow side of the symbol, huh? See how the x is on the narrow side? So what is x? X is less, isn't it? And where's the lesser stuff? To the left or the right? Over here to the left, right? The more negative numbers, the lesser numbers are to the left. So x is over there, so the shading must go that way. And do we have a parenthesis or a bracket? Yeah, no bar here, no equals bar. So there's no bracket, there's a parenthesis. Is that making sense? And then finally, interval notation. Remember how that always goes? That's the two parentheses, left edge, comma, right edge of the chunk of shading. So what's the left edge of the chunk of shading? Yeah, this left edge is negative infinity, isn't it? It goes left forever. So that left edge is negative infinity. And the right edge is -1. Parentheses on everything. There's no bars and no brackets. Back there to number, so we see the answers we have here, this answer and this answer. If you go back to number 14 in the handout, I don't know if you can see it, but I can't see it, right? I'm not making these small anymore. But it's basically this one. It's like too small to see probably on that screen for you, but it's A. So the main thing I would say is just look right here. It's this and it's that. There. Whatever it said. Yeah, so it's not A, it's D. Yeah, I'm just going to leave it here. No more looking at that for me. It's that. Whichever one says that, that's the one. That's the one on that. Let's try 15. In fact, yeah, I think I'll do 15 with you. So, what do we do about fractions? We have fractions here, right? Fractions is the problem. What do we do about fractions? What should we do about fractions? Yeah, by the denominator, huh? Whatever, because you want them out of there, right? Fractions are a big pain. We want rid of them whenever we see them. Okay, so what am I going to do? I'm going to multiply through by 4. 4 here, 4 here, and 4 here. Now, a good question that I'm often asked, it's a good question, is, hey, Mr. Tarrant, why didn't you put a 4 there and there? I thought you had to, go to everybody, do equal treatment to everybody. It's a great question. And the reason is because when you have parentheses, whatever happens in the front will eventually carry through those parentheses on the next step, won't it? So by doing the front of the parentheses, you really have done everything inside the parentheses. It'll eventually distribute in. Does that make sense? You do it just like you just do the outside, and that takes care of it. Is that good? So whenever we have a fraction, you multiply all the terms by the denominator, and then what happens from there? 4 over 1, cross cancel, huh? That's why we're doing it, right? Because we want to get rid of fractions. And that'll cancel out that fraction, won't it? And so that brings down just the 1. On the other side's 4x plus 36. No more fractions. Much nicer, huh? See what happened there? So whenever you have a fraction, whenever you have a denominator, you multiply through by that denominator to get rid of it. But you got to do all the terms left and right. With parentheses, you just do the front, and that takes care of it. Can you take it from there now? Go on and solve for x. So we want a number line. And then we want an interval notation, which means left edge, comma, right edge, huh? All right, so I'm going to distribute here. So x minus 6, 4x plus 36. Okay, so what do we do when we have x's on opposite sides? This is the wall here, right? When you have x's on opposites, remember, it's the x's first. Don't worry about that 6 and 36. They're down the river. First, we got to do something about that x and 4x. They're our first order business. Get rid of the smallest one, huh? Now, really, you can get rid of either one. It doesn't really matter. But yeah, usually I just say get rid of the smaller. Who's the smaller one? Plain x, huh? So I'll subtract x from both sides. You could subtract 4x from both sides. That would work great, too. Either way is totally fine. Okay, so then what do we get? Well, these cancel. We get minus 6 greater than. What's 4x minus x? 3x, right, because there's a visible 1 there, huh? Okay, now x is yelling out. What's x always yelling out? I want to be alone over here. So what do we got to get rid of? 36, huh? Got to get rid of the 36 because x is a big loner. Nobody wants to be with x. So subtract 36, boom. There we go. So 3x. And this, just use your calculator. It's minus 42, or just if you just think money, right? If you lose $6 and lose, negatives or losses, right? If you lose $6 and lose $36, you lost a whole bunch of dollars, $42. Last step to get x alone is always, almost always, divide. Divide. Now, do I need to flip the symbol? We just talked about dividing and flipping. Do I need to flip it here? No. When do I need to flip it? When you divide by a negative. If that was a negative 3 that I was dividing by it, right? Look back at the rule here. When you multiply or divide by a negative number is when you need to flip it, huh? Not a positive. So I just leave it. I'm not dividing by negative 3. I'm just dividing by a regular 3. And what do we get? I'm kind of running out of room here, huh? What do we get there? This is x, and that's negative 14?
Yeah.
Okay, let's go to the number line now. Now, a lot of people get confused by how to handle that symbol when the x is on the right. That's why I wanted to, it's probably the main reason I wanted to show this example, was how you handle that at the end. It trips up a lot of people. What I would suggest, if you can read it, great. Some of you can read it, great. Just do it, no problem. But if it's tripping you up, what you could, and the x is on the right, it's kind of bugging you and confusing you, you could always just flip the whole thing around. But when I say the whole thing, I mean flip everything. The x, the symbol, the numbers, everything could trade sides, and it'll be the same statement. In other words, x, that's saying the same thing. Let me get this out of the way. Those, get a little more room here. So I'm going to flip it. Those are saying the same thing, and this one might be easier for you. Just see, now, how do I know those are saying the same thing? Well, what side is x on here? The narrow or the wide? The narrow. What side is x on here? Also the narrow. Same. Huh. Those are, in both cases, those are saying x is smaller than negative 14, aren't they? See how they're both really saying the same thing? So that's what I was saying earlier. It doesn't matter which order things come in. You can have the x on the right or the left or whatever. And those two statements are actually the same, aren't they? Right? So I just grabbed this statement and I just flipped the entire thing around, including the symbol. And I didn't change anything. X is still smaller than negative 14. Let's go to the, now it's easy to go to the number line, right? We'll put negative 14 on the number line. Am I going to shade the left side or the right side? Yeah, because x is smaller. So it goes to the left. X is over here, smaller than negative 14. Parenthesis or brackets? Parenthesis, because there's no bar, no brackets. And now, finally, interval notation, which is left edge, right edge. What's the left edge? What's the left edge of the chunk of shading? Negative infinity. Huh? Negative infinity to negative 14. Parentheses. There we go. The answer in 3 different forms. Okay, so here's number 16. This is called a compound inequality. Compound, because it's got 3 parts to it. Right? Like to say, like if you break your arm really badly in a couple spots, they'll call it a compound break or something. It just means, there's a lot to it. So this is a triple. There's not just a left and a right, there's a left, middle, and right. There's 3 parts. But anyway, it doesn't matter. We just really do the same thing we always do. You just kind of look at where x is. X is in the middle. So just focus on x. And what is x always yelling out? Wherever x is, I won't be alone. So get rid of everything with x. So what's my first step? Just all I'm looking at right now is this. I don't care about anything else right now. Just 2x plus 2. X wants to be alone. So what do I do first? Gonna subtract 2. Right.
Add it to the other side.
Right. So you always do this. So subtract 2, and whatever you do to one part, you do to all 3. Yeah, you just do the same thing to all three. Not much different at all. Just do the same thing to all three like that. These cancel. We get 2x. This is negative 2. 8 minus 2 is 6. It's good so far. Next step, x is saying I want to be alone. So what do we do next?
Divide everything by 2.
Divide everything by 2. And we get x. This is negative 1 and 3. So there wasn't much new there, right? It's just whatever you do to one part, do to all three parts. Now let's put that on a number line, and let's write that in interval notation. So now we have a triple with 3 parts, and that actually makes it way easier, really. You'll find these super easy to put on the number line in the interval notation. You don't have to really think a lot about things. That x is right in the middle between a negative 1 and a 3, isn't it? So that means you just bring down a negative 1. Parentheses or brackets on this one? Yeah, we have bars on both these, don't we? So that means we're going to have brackets. So you just bring down the negative 1 and the 3, and the x is between them. So the shading is between them. The x is between them. There we go. And how do we write that as an interval notation? You know, left edge, comma, right edge. Well, it's pretty obvious. Negative 1, comma, 3. And we're done. So it's, let's try number 17. Small again. Yeah, thanks. It's positive because it's the most important. So going to multiply through by 5. So 5 here, 5 in the middle, 5 on the right. And in the middle, it cancels, right? That was why we were doing it, because we wanted rid of that fraction in the middle, huh? And so what do we get? Negative 20, 3x minus 6. And 5 times 0? Still just 0, huh? Is that good to there? Much nicer when the fractions are out of there. Does everybody see what happened? That's what we always do. Get in the hang of that. Whenever we have fractions, we just multiply through by that denominator, all the terms. All right, take it from there, and when you get done, write your answer on the graph, in the interval. So x is saying, I want to be alone. So add 6 to all 3 of these. This cancels. And we get, what do we get here? We're going to get negative 14, 3x, and 6. Last step is to divide, right? We're going to divide through by 3. And so, what do we get? These cancel. And x, this is 2. Do I need, no, yeah, negative 14 thirds. I didn't turn the symbols because I divided by a positive number, not a negative number. Remember, it's only when you divide by a negative that you need to flip the symbols, right? So we're good to there. There's our answer. And that's pretty easy. It's kind of weird we have a fraction, but that's okay. That is our answer. And so now let's put it on the graph. So I'm going to stick it on the graph like this. Just really straight ahead. You just put negative 14 thirds there and 2 there. Is it going to be parentheses or brackets? Parentheses, right? No bar, no brackets, right? There's no equals bars here, are there? No equals bars, no brackets. Going to be parenthesis, parenthesis, shading in between. And last step, let's do interval notation. And that's pretty easy. Parenthesis, negative 14 thirds, comma 2. So it's nice when there's 2 numbers. You don't have to think a lot about, right side, left side. It's just the x is in the middle. The shading's in the middle. Just put down the 2 numbers and you're done. Good there? Questions on that one? All right. I'm going to move ahead. I'm looking and seeing some difficult ones. I want to get there with you. 19. I'm going to skip 18. It's not simple either, but 19 is worse. Let's get to 19. Okay. Look at that one. That's a bad one. Look at all those fractions. What do we do with fractions? Get in the game plan. What do we do with fractions? We multiply through by every single item that's in a denominator, under a bar. Everybody by all of them. So in other words, I'm actually going to take 4 times 7 times 3. And actually, I'm not even going to figure out the number. I don't really care what the number is. I'm just going to say, look, 4 times 7 times 3 to that guy, to the left, and then 4 times 7 times 3 in the middle, and 4 times 7 times 3 on the right. Is that making sense? Do you see how we always handle fractions? We multiply through by everything in the denominator, top, top, top. And now just cancel out whatever you can cancel. And what can I cancel on the left side? The 4 cancels, and so whatever is left over, whatever doesn't cancel, we just go ahead and multiply, huh? So 3 times 7, 21. How about the middle? What cancels in the middle?
7.
Yeah, the 7s cancel. So what's left over in the middle? 12. 3 times 4 is 12. And then go ahead and I'm going to put parentheses x plus 1. You might say, well, where'd those parentheses come from? Well, it's because the 4 times 3, the 12, needs to multiply the whole x plus 1. So you could do it right now. I could have just made it 12x plus 12. You could do it all in one step if you want. I'm just going to go slow and do it in 2, but either way is fine. Does everybody see what happened there? The 4 and the 3 multiply to be 12, and then they're going to also multiply here. On the other side, the 3's cancel, and what do we have? Well, 4 times 7, and then another 7, huh? We have the 7 that was there from the beginning. Right, there's 2 7s and a 4. 4 times 49 is like 396 or something. I don't know, I'm kind of guessing. 196. Is it 196? Yeah, 196. I'm going too high. 196. Just use your calculator. 7 times 4. Everybody see what happened there? 7 times 4 times 7 were all left over. The 7 that was there from the beginning, along with the other 4 and 7. Then the middle, and look at that, no more fractions, huh? See how much nicer it is? So what do we always do with fractions? We get rid of them by multiplying every item in the denominator, top, top, top. All right, the rest is easy. 12x plus 12. X is saying I want to be alone, so subtract the 12. And what's this, 9? 184. Last step, divide by 12. Now 9 twelfths, how do you reduce 9 twelfths? Divide by 3, top and bottom, right, becomes 3/4. And 184, is that just divisible by 12 on a calculator? No? I don't know, I'm just guessing. Yeah, I have no idea. No, okay. You can divide by 4, I think, right? That'd be 92, 46 thirds. I think I got that right. Is that right? Is that what's coming out there? For you, that coming out okay? So there we go. And you could put it on there. I really want to move on with harder things with you. You could put it on an interval, and it's just straight. It's just like that with the 2 numbers on the graph and the 2 numbers in the end. That's the bar. There should be a bar all the way down. Oh, not the one on the right, huh? Just the one on the left. I wasn't even looking close. Yeah, the one on the left has the bar, and the one on the right does not. Yeah, so when you write that as an interval, remember it'll be bracket on the left, but parenthesis on the right, huh? Because there's no bar on the right, there is a bar on the left. Thank you for that correction. We're about to go into absolute value greater than, less than. Okay, think with me for a minute. What if somebody gave us this question? Absolute value of x is less than or equal to 2. What do those straight bars called absolute value do to anything you put inside them? Make it positive, don't they? They just make it positive. Okay, so just think with me. Suppose we have no idea how to solve this. We're just looking at this going, I don't know. And we just thought logically for a minute. That's always the best thing. Math is just logic written out. So you tell me, what numbers could I put in there for x that would make the statement true? That's what solving a equal sign or greater than, less than problem is always about, huh? Making it true. So what could I plug in there to make it true? I could plug in -2, -1, 0, 1, or 2. Couldn't I? Does everybody see that? Any of those numbers, the absolute value of them would be positive, and then less than 2. Less than or equal to 2, wouldn't it? Is that good? So, what's my point in that? In other words, it's all the numbers like that, isn't it? It's all the numbers between -2 and +2. Now, on the other side, let's think about if we had absolute value of x greater than. In fact, let me just change the color for emphasis. Absolute value of x greater than, instead of less, greater than or equal to 2. So what numbers could I plug in there to make that true? Yeah, I could plug in 2, 3, 4, 5, and on you go, right? That's some of the numbers I could plug in, right? 2, 3, 4, all those. The absolute value would be greater than 2, greater than or equal to 2. And what other numbers? Those aren't all the numbers. 2 on up. Remember, absolute value makes anything positive. I could plug all those in negative, couldn't I? I could plug in -2, -3, -4, -5, and on down you go, couldn't I? Right? You put in something like -3 here, the absolute value of it will make it +3, and that is bigger than 2. That makes it true. You tracking with me? So you could plug in negative numbers, 2 or bigger, or positive numbers, 2 or bigger, just the opposite of the answers from the other side of the wall there. Right? Those are all numbers smaller than 2. These are all numbers 2 or bigger. So how would we say that? How would we say those numbers? We would need to say all the numbers less than or equal to 2, that's all these numbers. Or all the numbers greater than or equal to +2, that's all these numbers. We would need to say it in 2 separate statements. It's 2 separate lists, isn't it? You see that? You see the truth of that? Right? All the negative numbers, -2 or below, less than or equal to -2, right? Those are all the numbers -2 or less, right? More negative. And these are all the numbers 2 or bigger, greater than or equal to 2. It's 2 separate lists of numbers that would make that true, huh? Does that make sense? Maybe a number line would help just to visualize it. On a number line, what we're seeing is all the numbers from -2 this way, right? Like -3, -4, -5, etc. And all the numbers from 2 on up, like 3, 4, 5, and on you go. Huh. See that? Whereas on the other side, what are these numbers on the number line? Well, they go from -2 to 2, right? Like -1, 0, 1. They're all the numbers captured in between. See how it's just the opposite in the forms of their answers? So it makes a big difference, doesn't it? Whether you have absolute value less, you're going to have a chunk of numbers in the middle. Or absolute value greater, you're going to have 2 separate chunks, aren't you? Do you see the truth of that? So that truth, right? I'm just saying, what are all the numbers that you could make them positive and they come out 2 or bigger? Well, all these numbers, if you make them positive, they come out 2 or bigger, don't they? And of course, all these numbers already are positive, so they're 2 or bigger. Whereas these numbers, if you want it smaller than 2, it's all the numbers between -2 and +2 that are all smaller than 2 when you make them positive. Okay, so if that's the case, that leads us to 2 general game plans, and that is the following. If you have absolute value of some inside, what was the left side? Less than or equal to a number. what should you do logically? Well, what happened over here? This. So you should put the inside with a couple of symbols this way, right? Isn't that what we did here on the left side? And this number, the positive version is there, positive 2, and the negative version is there, huh? See that? So generalizing, we'll say, oh, so put right here the positive number and put over here the negative number. Solve it, and you're going to end up having negative something, comma, positive something in the end, aren't you? Which is what we ended up with there. Whereas the right side, if somebody gives you an inside greater than or equal to a number, like this right side was, what happens there? Well, we get that and that. We get two separate, notice that, two separate x inequalities to solve. This one and this one with an or in the middle. Two separate lists, huh? So what's this one? Well, the inside smaller than the negative version of the number. So the inside smaller than the negative number. Sorry, I'm getting a little scribbly there. Inside smaller than the negative number. Or, what's on the right side? The inside greater than the positive number. Inside greater than or equal to the positive number. And then you solve this, and you solve that, and what do you end up with? Negative infinity, comma, a number, or a number, oh, this should be a bracket, my mistake, comma, infinity. Why? Where's that coming from? That's what this says, right? This goes from negative infinity, doesn't it? To negative 2, and this goes from 2 to infinity, right? Is this infinity over here? Right? See the form of that answer on the right side? And what's in between? You put a U. Have you seen that before? You put a U, it unites them. That stands for unite. So instead of the word or, they just have us put a U like that. So that's the format. That's the setup we should follow whenever we're solving an absolute value less than or greater than. That's a great thing to put on your 3x5 card. Probably the most important thing we've had so far. That you want to have, you get that 3x5 card, right? Write anything you want on both sides for the exam we're taking a week from today. So definitely put that on. And then we'll take a break and we'll solve some of these after. Go to that right here. So on this line and this line, absolute bars are gone on the second step, aren't they? So notice that the absolute bars are gone on the second step, right? We had absolute value bars in the beginning, but we remove them logically correctly as we reasoned out right here to prove that's true. All right. Let's dive into the homework on this one. So, okay, so we're trying to take that and solve for x. Okay, so what did we just learn you do? What is the game plan for absolute value? And you want to look, it's a big difference, isn't it, whether it's absolute value greater or absolute value less. This is absolute value less. So let's go back to our game plan. Which side is the less side, the left or the right there? The left, right? This is less, right? Absolute value less. So we're going to follow this game plan for this problem. You tracking with me? I'm showing you what to do if you have absolute value less on the left, absolute value greater on the right. This, right? This is absolute less, and this is absolute greater. You seeing the differences there? So we're doing absolute value less. So what am I going to do? I'm going to remove the absolute value bars and make a triple statement, aren't I? Right? So we do that. I say, all right, yank off the absolute values. No more absolute values. Make a triple statement. And you put the negative number on the left and the positive number on the right. So I take this over here, negative 6 and positive 6, and then I solve from there. So now, let's finish from there. What do we do from there to get x alone? X is saying I want to be alone. Divide through by 6, right? And then, this is negative 1, this is positive 1. There's our answer. How do you write that as an interval? Parenthesis, negative 1, positive 1, huh? It's all the numbers between negative 1 and positive 1. Okay, so go ahead, follow the plan. First step, I'm going to yank off the absolute values, and I'm going to write two separate statements, aren't I? See it back here? It's going to be one statement there and one statement there with an or in between. It's two separate statements instead of one big triple statement. See the difference? For absolute value less, you do one big triple statement. For absolute value greater, you do two separate statements with an or. The first one has less than the negative number. The second one has more than the positive number. So let's do it. So less than the negative number. The second one has more than the positive number. It's very important that you get those symbols facing the right direction. It matters a ton to have it the right direction. See how that's exactly imitating the format? Two separate statements with an or. The one on the left is less than the negative. The one on the right is greater than the positive. And then just solve them both separately. So what do I do to get x alone? Divide by the 4. Negative 6. Divide by the 4. Greater than 6. All right. Now, they're going to want you to give interval notation answers and a number line. So let's go to the number line first. This is going to be, notice it's two separate x's, isn't it? So that means it's going to be two separate sections shaded on the number line. How do you do this one first off? It's all the numbers less than negative 6. So I'm going to put negative 6 here, positive 6 is over there. Where I'm going to, the x is the shading is the numbers less than negative. Right, just like before. Yeah, so less than negative. So which way is shaded for, where are the numbers less than negative 6? Left side or right side? Left side. So it's going to go parenthesis, shading that way. This one's going to go parenthesis, shading that way, isn't it? Because it's greater. The x is greater than negative 6, positive 6 here, and the x is less than negative 6 there. Yeah, parentheses, there's no bars here, unlike the example I gave you on the board and on the handout here was bars. But you know that rule already, right? So no bar, no bracket. These are parentheses. These are parentheses. Okay, so now they want you to turn both those into interval notation answers. How do I write this as an interval? Remember intervals? Left edge, comma, right edge. What's the left edge of that chunk of shading? Negative infinity. Negative infinity, negative 6. United with, put a U, left edge, comma, right edge, 6, comma, infinity, right? Left edge, right edge. And there is our final answer. So notice that the absolute value greater problems always end up with a greater number of answers. Two parentheses or brackets or whatever. Two separate answers, right? The absolute value greater end up having two x's, two shading chunks, two intervals. Whereas, come back to number 20, absolute value less than problems end up having one x, one interval. Absolute value greater end up with two x's, two chunks of shading, two intervals. Greater has more, less has less. All flowing from that original logic we looked at. That makes sense there? Questions on that one? So it's a world apart, right? How you handle absolute value less or greater. All right, I'm going to move on to 22.
Another way to compare on our
Let's try that one. So the first thing to decide, is this a less than problem or a greater, so you know which. What's it say you do first? You remove the absolute values. Is this the one we're going to make one big triple statement or two separate statements? So one statement, right? Remember, less is less, more is more. So less is one statement, the greater is two statements. There's going to be one statement. You put the -4 on the left, the +4 on the right, and no bars. You remove the bars. And how do the symbols go? Look at the example. Go back to the example. The symbols are both less, aren't they? They're both less. So we go both less. Like that. Not good? Keep going. Now, focus on the center. X is saying, I want to be alone. So what's my first step to get X alone? Add the 9 everywhere? Yeah. Keep going. That first step's the most important. Does everybody see how that first step happened? I yanked off the absolute values and made a big triple statement. Okay, so we add 9 to all 3. And we get like that. And the last step to get X alone, divide through by 7. And there we go, right? Is that good? And they want an interval notation answer. So I'm going to go bracket 5 7s, 13 7s, right? It's just one bracket is the, right? Instead of two, right? The less is less, the greater is greater. The less than problems have one bracket or parenthesis at the end. The greater have two brackets or parentheses at the end, don't they? So there's our answer. Questions on that one? Try that one. You know what to do. So decide if it's greater than or less than, whether you make the one big statement or the two separate statements. So first step, this is absolute value greater. So we can have the one big statement or the two separate statements? Two separate. Yeah, because it's greater is more, two statements. And to see the direction, it's less than the negative one or greater than the positive one, isn't it? Right? It's super small, less than the negative, or super big, greater than the positive. It's the two edges. And then solve for X for both those two separate equations, or inequalities. Solve for X. And remember, if you divide by a negative, you got to flip the symbol. And right there I'm doing it, huh? I'm dividing by a negative number, aren't I? So right there, right then, scratch out the other symbol and turn it the other way. That makes sense? X is greater. And right here, what do these two negatives do? Become positive, right? Two negatives become positive. And then the other side's the same thing. And that 3/6 reduces to be a half. Oh, I forgot to flip the symbol, didn't I? Press this out, turn the symbol the other way. Everybody good with it? I just divided 3 into 6 2 times. So it became negative a half. Is that good to there? They want us to write an interval notation answer at the end of this. Yeah, interval. Notice this is the one that's usually on the left side, huh? He's the negative and he's the less than case. And this is the greater. So he's going to go over here, actually. And he's going to go over there. They've switched. You don't have to move them, but I think it might make things easier for you to see. Right? Because we turned the symbols, their roles have changed. The left one is the less. The right one is the greater. So then this is going to be, now what's the format look like? Look back at the setup. Let me help you. See back here with the greater than, you're going to have a negative. Notice, let me help you make another observation. Notice that the absolute value greater always ends up having two sets of parentheses or brackets and has the infinities, doesn't it? Has the negative infinity on the left and the positive infinity on the right. It always will. Whereas the other one, the absolute value less, that doesn't have any infinities. It just has one bracket or parenthesis at the end, not two. Whereas the greater always has the two with the negative infinity on the left and the positive infinity on the right. That'll always be the case. So if you have this on your 3x5 card, it'll really help you. You'll know the format. And the answers are multiple choice. So right away you'll know that'll really limit the possibilities. You'll see on practice exam day, which is just Thursday, day after tomorrow. So you'll see what I'm talking about. So anyway, so this is going to be negative infinity here. This is going to be infinity there, always, And then just pop in the negative a half, pop in the 13/6, put a u in the middle. No brackets, there's no bars here. And so there's our answer. So 24 has absolute value minus 2x plus absolute value minus 5 less than or equal to 9. Let me help you notice something. Do you notice that? Can you read my scribbles up there? So notice that the second absolute value, this is question number 24, is just on a number. So if there's no x there's an x on the first one, and we'll need to do our normal thing with that one. But for that second one, that's just a number. What's the absolute value? Negative 5. It's just 5. You don't need to do any fancy stuff with that. Right? All the fancy stuff that the two formats that are on the board and in the notes, that's when you got an X in there. And that's the first one, yeah. But so my point is, and then what about this negative sign on that guy? Just make it positive, So just make those positive. But we're not done with the first. See how I removed the second absolute values? There's nothing more to do with him, right? The absolute value negative 5 is 5 and they're gone. Right? They make them positive and they leave. Now the other one has an X though, so I'm still going to have to, do the thing we learned about. That was all reasoning from an X, remember? An unknown. But first, you know what we should do first? A lot of math, if you're going the STEM road, you're going to take pre-calc trig and calc and stuff like that, is learning to recognize the forms of things and making sure your whatever matches the form and you follow the yellow brick road when you see the form. What am I talking about the form? Well, look back at the form I gave you. There it is. And tell me what we need to do to make our problem look like that. Notice the very first step has absolute value of some inside, and that's the whole left side. There's not a number like a +2 or something over there on the left side with it, is there? The absolute value is the whole left side for both those examples, isn't it? There's no number or anything outside of the absolute value on the left side with it, is there? So my point is, if you want to follow those steps and let those steps guide you to the right answer, and they will, as long as you make yours match theirs first. That's like all of math and science. Well, not all, that's dramatic. That's a lot of math and science right there, especially math, is making your whatever fiddle with it until it matches the rule you've been given, and then just follow the rule. So the rule is, hey, if you've got absolute value of the left side, with nothing else on the left side, and then a greater than or a less than with a number on the right, here's what you do, right? So we got to go back to our problem and go, oh, okay. Well, I've got an absolute value on the left side. Oh, but I've got a number. So I got to get rid of that guy. And then mine will match their format. Then I can follow their steps. See how that's all occurring to me? I've got to make my thing match the rule. So what do I got to do first? Yeah, just subtract the 5 from both sides, right? Just get rid of that guy. So then we have absolute value 2x less than or equal to 4. Now we match the format, don't we? See how so now it matches the format that I gave you. Why? Because there's an absolute value on the left side, 1. I didn't give you any rule about 2 absolute values. That's why I got rid of this one, huh? 1 absolute value on the left side, nothing else, and a number on the right. That's the format for the rule we were given. So now we can follow the rule. At this point, we can follow the rule. And what does the rule say? First step, yank off those absolute values. So is this one a less or a greater? Less. So is it going to be one big statement or 2 separate? One big one, right? Because the greater is more, the greater is 2. So one big statement. Both symbols are less than or equal to. In this case, less than or equal to. And I put the negative 4 on the left and the positive 4 on the right. That's what the rule says, right? We'll go back to it real quick. It says when you have one absolute value on the left side, number on the right, you put that thing in the middle, the negative number on the left side, the positive number on the right side. With no more absolute values. You yank them off. So I go, oh, okay, I'll do it. So I yanked them off, put the negative number on the left, the positive number on the right. Now how do we finish solving for x? Divide by the 2. Do I need to flip the symbols? No, I'm dividing by a positive number, not a negative, right? And so we get negative 2. These cancel. Positive 2. How do we write that interval? Negative 2, comma, positive 2. Done. Brackets, right? Bars, brackets. Solid bars lead to brackets. 26 has some words. Let me go back there. No, those words are hard to read. All right. They're too tiny because I made everything so small. All right. I'll write it here. 26. It basically says x differs from 6 by less than, f differs from 6 by less than 6/7. And they want me to write that, first off, as an inequality. X differs from 6 by less than 6/7. So it's going to be absolute value of x minus 6, so part A, less than 6/7. Like that. Absolute value of x minus 6 is less than 6/7. Value comes in, and then you just solve it. Oh, and that part B? Yeah, part B they want you, so I'm going to go dot, 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 then you just solve it. Let's try, and then 27 is going to be the same thing. 27 says x differs from -5 by more than 8. By more than 8. Can you try that one? They want you to write part A. They want you to write that one as an absolute value inequality. Be careful. Watch your signs. Got to put in there minus a -5, don't we? Just like this one was x. The word differs is your subtraction, right? If something is the difference between two things means a subtraction between them, doesn't it? So the word differs carries a subtraction symbol, and then you put the other number. Well, in this case, the differs is the subtraction, and the other number is -5, huh? Did you see that? More, greater than 8. So yeah, it'll actually end up being x plus 5, won't it? In the end, when it's simplified. Everybody see that? And then they'd have you solve it in part B, but we solved enough of them.